What if the sky suddenly turned into a living painting? Vibrant green and purple waves dancing right above your head. Not in Iceland, not in Norway, but right over New York, Chicago, and even California. Sounds impossible? Well, it's happening. And it's not just a light show. Over the next few days, Earth is stepping into the path of some serious solar activity, and it's going to shake things up. We're talking about powerful solar storms, massive bursts of energy from the sun, heading straight toward us. And when they hit our planet, they interact with Earth's magnetic field, lighting up the sky with the incredible Aurora Borealis. But there's more to this than just pretty colors. These solar storms can also mess with satellites, GPS, even power grids. So yeah, the sky might look magical. But what's really going on up there could be a whole lot more intense than it seems. The northern lights are a natural light display that appears in the skies over the polar regions of the northern hemisphere. Shimmering, colorful, and completely real, they show up when solar particles collide with gases in Earth's atmosphere, releasing energy in the form of light. These lights appear at high altitudes and form patterns that seem to move and pulse, like living waves across the sky. Green is the most common color, but you can also see blue, red, and even purple, depending on which gases are involved and how high the collisions occur. It's a phenomenon made possible by the interaction between the solar wind and Earth's magnetic field. That's why it's mostly visible near the poles. The closer you are, the more frequent and intense the display. While it's known as the Aurora Borealis in the north, the same effect happens in the southern hemisphere, where it's called the Aurora Australis. It's not magic, but it sure looks like it. It's pure physics, with one of the most surreal visuals nature has to offer. Seeing the northern lights in person is like watching the sky dance, but with strict rules. They don't show up just anywhere, or anytime. The best spots are close to the Arctic Circle. Norway, Finland, Sweden, Iceland, Canada, and Alaska are the main stages for this natural show. The farther north you go, the better. But there's another catch: the season. Auroras love winter, not because of the cold, but because of the darkness. In polar regions, winter brings long nights, and the darker it is, the clearer the view. Time of night also matters. Scientists say the best chance is between 10 p.m. and 2 a.m., when auroral activity tends to peak, and the sky has to cooperate. Clouds, fog, or city lights can ruin everything. You could be in the perfect spot at the perfect time, and still see nothing. It's like trying to watch a movie on a blank screen. And finally, even in ideal conditions, there's no guarantee. It all depends on solar activity. If the sun's quiet, nothing happens. But if a solar flare hits, then the sky becomes a moving masterpiece. Some people look up at the sky and think, that's gotta be magic. But what's happening up there? It's pure physics, the kind that gives you goosebumps. It all starts with the sun. It's not that calm, glowing ball it looks like in photos. It's a fiery, chaotic beast, constantly throwing off charged particles in all directions. That's the solar wind. When that wind hits Earth, it slams into our magnetic field, which works like an invisible shield wrapped around the planet. But the shield doesn't block everything. It redirects a lot of those particles toward the poles. And that's where the magic kicks in. When those solar particles crash into our atmosphere, they collide with gases up there, mostly oxygen and nitrogen, and those collisions create light, literally. The sky lights up in response to energy from the sun. Each gas reacts differently. Oxygen gives off that classic green glow. Nitrogen can produce blues and purples. And during really intense solar storms, you might even catch red, which is way rarer. And those shapes in the sky, the curves, spirals, the curtains that seem to dance, that's all shaped by our magnetic field lines. They bend and mold the light, like invisible paintbrushes sketching across the sky. So when you see the northern lights, you're actually witnessing a high-speed reaction between the sun and the Earth, a light show powered by solar storms, traveling millions of kilometers and wrapping around a planet with just the right kind of magnetic field. And the wildest part? This all happens around 60 miles above us, way higher than any cloud. So when the sky's clear and the aurora shows up, it's like the universe is putting on a show just for you. You don't need to be standing at the North Pole to see this show, but the closer you are, the better. The most popular spots to watch the aurora are northern Norway, Sweden, and Finland, plus Iceland, Canada, and Alaska. Some of these places even have glass-roofed cabins, guided tours, and real-time aurora alerts, all set up just for this. But here's the cool part. Sometimes the aurora shows up in places way farther south than usual. During stronger solar storms, people have spotted it from places like Montana, Michigan, even New York. Now, when's the best time of year to see it? Between September and March in the northern hemisphere, when nights are long and dark. The SAO. Prime time is usually between 10 p.m. and 2 a.m., when the skies tend to be clearest and darkest. But timing isn't everything. You'll need clear skies, no clouds, and as little light pollution as possible. The farther you are from city lights, the better your odds of seeing the full show. Some people travel the world just to catch it, and it makes sense. Seeing the aurora with your own eyes is something you never forget. It's not just beautiful, it's hypnotic. Like the sky is alive, dancing, glowing, shifting colors. It feels like the Earth itself has a soul. While the skies were exploding in vibrant colors down on Earth, the impact wasn't just a light show. Intense solar activity messes with everything we rely on daily. GPS signals drop out, planes reroute, satellites lose contact. It's like the planet suddenly forgets how to navigate, communicate, and protect itself. Power grids go on high alert. In 1989, a solar storm caused a 9-hour blackout in Quebec, Canada. And that was decades ago, back when we weren't even half as dependent on satellites as we are today. Now, a similar event could cause billions of dollars in damages. And it's not just about money. Hospitals, transportation, security, everything could take a hit. So, the aurora isn't just beauty in the sky. It's also a living warning. We live under a powerful, unpredictable star. The aurora isn't just beautiful. It's the visible proof that our planet is defending itself. It all happens because of Earth's magnetic field, that invisible shield that protects us from dangerous solar particles. When these particles hit with force, they try to break in, but the magnetic field reacts like a war shield, deflecting most of them. What gets through slips in through the poles, where the shield is weaker. Up in the atmosphere, these particles collide with gases, like oxygen and nitrogen, and boom, that's what creates the light show. Seeing an aurora is like watching Earth's defense system in real time. But that shield isn't always perfect. It shifts, weakens, and changes. And when that happens, the auroras shift too. Some years they're barely visible. In others, they show up in places no one ever expected. So every time you catch a glimpse of an aurora, know that there's an invisible battle playing out right above you, Earth versus Sun. There's a mystery that still puzzles scientists and aurora hunters: the sound. That's right. Some people swear they hear a faint crackle, a hum, or even a whisper when the aurora appears in the sky. And it's not just a few individuals. These reports go back over a century, from different corners of the world. But how can anyone hear a phenomenon happening over 100 kilometers above the ground? The most accepted theory is that the sound doesn't come from the aurora itself, but from atmospheric electrical discharges closer to the surface. These are triggered when charged particles interact with Earth's magnetic field and cause shifts in the air's electrical properties. Other researchers believe it might be psychological, an auditory pareidolia, the mind filling silence with what it expects to hear. But to this day, no one has recorded a clear, undisputed sound coming from the aurora. It's as if nature wants to keep that part of the experience exclusive, a secret between the sky and those who witness it. Earth isn't the only planet with auroras. In fact, our solar system is full of worlds with dancing lights, and each one is uniquely stunning. Take Jupiter. It has the largest auroras in the entire solar system, but they're not just powered by the sun. One of Jupiter's moons, Io, dumps volcanic material into the planet's magnetosphere. This fuels massive auroras that glow in ultraviolet, completely invisible to our eyes, but stunning through NASA's instruments. Saturn also has its own version of auroras. They show up near the poles too, but form glowing rings that look like light belts. Its magnetic field interacts with the solar wind in a unique way, creating complex patterns scientists are still trying to decode. And Mars. Even though it lost most of its magnetic field billions of years ago, it still has patchy auroras. These show up in spots where the crust is magnetized, like tiny sparks of light triggered by the planet itself. These phenomena prove that auroras aren't just a terrestrial spectacle. They're cosmic signals, powerful, active, and often invisible. For centuries, auroras were just a visual mystery, but in recent years, they've become a powerful tool for scientific discovery. Researchers are now using polar lights to understand phenomena far beyond Earth's atmosphere. Satellite data shows that auroras help map the Earth's magnetic field in real time. They act like a natural space scanner around our planet. Thanks to this, scientists can predict navigation system failures, prevent power grid blackouts, and even shield space missions from danger. And it goes further. Auroras have inspired new technologies. For instance, communication systems designed to mimic how solar particles interact with Earth's atmosphere, leading to more stable connections in extreme environments. The aurora is no longer just a light show. It's now a data-rich phenomenon connecting space research, innovation, and the safety of our modern world. If you made it this far, congrats. You now know more about the Northern Lights than most people on Earth. Now tell me, which of these facts blew your mind the most? Drop it in the comments. And if you're into this kind of content, science, mystery, and jaw-dropping visuals, make sure to subscribe right now. We're just getting started. And don't forget to hit the bell, because the universe never stops, and neither do we.